Hello everyone, this is William from Visual Components. In this video, I'm going to talk about component path sensors. So I'm going to show you how to create a sensor, connect it to other behaviors, define the location of a sensor and when it's triggered. I'm also going to show you how to use a sensor with signals. So this video will be Python script heavy. I do make mistakes while making the Python script, but hopefully you'll learn from them. So right now in the 3D world, I have a basic feeder connected to a conveyor. So when I run this simulation, a part is created and it moves along the conveyor's path, like so. So what I'm going to do is go ahead and set up a component path sensor in this conveyor here. Now the components I'm using in this layout right now you can find in the Items by Type Component Templates collection. So I'll go ahead and start by going to the Create tab, make sure I'm working with the conveyor, and I'll go to the Behavior tab here, and I'll select Component Path Sensor from this drop-down menu here. This creates the sensor and opens its properties. I'm actually going to close the dialog now, and what I'm going to do first is actually connect the sensor to the conveyor's path. So I'll double click the path to access its properties. Let me go and make this bigger for you. And then I'll click this access button here for its sensor's properties to connect the sensor. Notice here's that sensor. I click the add button, and now the sensor is connected to the path. So I'll close these out. I'll now go ahead and access the sensor's properties and talk about them a little bit further. So these properties right here, distance and frame, these are for defining a location of the sensor. The trigger at property is for defining when the sensor is triggered by an object, for example the front or leading edge of the object, its origin, or its trailing edge, the back of it. You can also reset the sensor based on the object's geometry. And then you have these properties down here for component signal and bool signal. So component signal, when the sensor is triggered, you get the value of the component that triggered the sensor. A bool signal refers to a Boolean signal. So when the sensor is triggered, you get a true value or a false value. And if you want to have a false value when the sensor is triggered, you can use the bool signal value property here and deselect the checkbox. That will return a false value. But if it's checked, it returns a true value. Let's go and create some signals now and connect them to the sensor. So I'll close this. I'll go to the drop-down menu here and create a Boolean signal and a component signal. I'll now connect them. So I'll just select them pretty simple like this. And now the signals are connected to the sensor. And in order to really use this sensor, you have to create a Python script. Well, it's basically what I would recommend, because if you run the simulation right now, you don't really see an effect of the sensor. So I'll reset. And I'm now going to create a Python script behavior. And now you want to go ahead and connect your signals to your Python script. So when the sensor triggers the signals, the value of those signals is automatically communicated or sent to the Python script. You don't have to do any more like programming for that. So I'll double click the signal, and I'll use this connections property here. And I'll select Python script, and now it's connected. And I'll also do the same for the component signal. Okay, so now we have a basic setup for the component path sensor in the conveyor. Now, because I created all these behaviors on the fly, and it's also connected to a feeder right now, I need to go ahead and update the component. Now, I could save it, I could save the layout, or actually could just update the path of the conveyor right now in the Python script. So I'll do that now. I'll double click the Python script behavior to access the editor. I'll clear this out. I'll first get a handle for the component. So comp equals get component, like so. I'll now get the path. So path equals comp dot. I'll use get behavior. And I just reference the name of the behavior, main path. And now I'll go ahead and use an update method. So I'll do path dot update. So I'll compile the code, and now I'm good to go. So I can go ahead and remove this if I want. And now I'll get a handle for the sensor in the component. So sensor equals comp dot find behavior. Now before I showed you how to use get behavior, let me comment this for you. So the difference between the get behavior and the find behavior methods is that the get behavior references the node that you're referring to in your script, whereas the find behavior is a little bit more robust. It actually can find the behavior in the component, all of its nodes and so forth. You just have to make sure you reference the right name. So that'll come into play a little bit later in the video. So let's get that sensor's name. So component path sensor. And also get a handle for the simulation objects. So sim equals get simulation. And now to show you the real strength of the sensor with its signals, I'm actually just going to use the onSignal event. So when those signals are triggered by the sensor, I can go ahead and set up some script. So I'm first going to say if the signal is equal to sensor dot, I'm going to use its component signal first. Go ahead and just halt the simulation, like so. So I'll compile the code, and now run the simulation, and nothing happens. The reason why nothing happens is because I actually didn't specify what the location of the sensor is in the conveyor. So I'll stop the simulation and reset it. And now I'm going to go down to the status bar and turn on the global visibility of frames in the 3D world. And you can notice the conveyor has frames at its beginning, its middle, and its end. So I actually can set the sensor to be at one of these frames. So I'll double left click the sensor, and for its frame property, I'll select mid frame. So what we should now see is a component stopping at this mid frame. So if I reset the simulation, alright, nothing happens. Let's actually go ahead and update the path again. So what I'll do is I'll get a handle again. Path equals comp dot get behavior main path. Let's go ahead and update it again. And it should work now. Yep, there you go. So the simulation is halted, and you can see there's that leading edge of the component right there. So now if I actually want to stop the component at its origin on the mid frame, I'll go and reset, double click the sensor, and I'll change the leading edge to be origin. So now if I run the simulation, there we go. Alright. Now if I want to get more information out of the simulation, I'll go and reset it, and I'll access the Python script. And now I can actually go ahead and remove this. Everything should work fine now. So now when the signal is triggered, I actually want to get the signal value. So I'll say part equals signal.value. And because it's a component signal, it will return the component that triggered the sensor. Part.container dot enabled equals false. So what I'm doing here is that the part is actually contained on the conveyor's path. So that container property is going to actually stop the path. So I'll show you. I'll compile the code and run the simulation. And there you go, it happens again. So if I actually want to create a handle for the path, I can do that now. So path equals part.container. And by the way, I'm using a VC component, VC script, VC behavior, and VC container as well. So if you want to reference those pages in the help document, you can. So now if I run the simulation again, actually let me modify the script again, sorry. So path equals enabled, path.enabled equals false. And then I'll go ahead and print the component's name like so. Boop. So the path is stopped, and there's the printed part. Now there are also other methods I can use to actually stop the component but not the path. So what I'll do is I'll reset the simulation. I'll go back to my Python script. And let's actually, instead of stopping the path, what I'll do is I'll say part.equals value. Then I'll do part.stop movement. I'll use this method here. And then I'll go ahead and print the part's name. So compile the code, run the simulation, and notice that the part stops, but the path of the conveyor keeps on moving. I'm now going to show you how to use the distance property for the sensor. The distance property allows you to reposition a sensor based on the path it's connected to, or the container it's connected to. So I'm actually going to create a node in the conveyor, to be the node of the sensor. So when I'm moving the sensor during the simulation or whenever I'm modeling it, I don't have to remodel everything and rebuild the geometry. So I'll go ahead and select the component's root node, and I'm going to hold down the left mouse button and drag and drop the sensor into link 1. I'll now access the sensor's properties, and for its distance, I'll go ahead and change it to be 200 millimeters. So I'll hit the enter return key and close, and I'll reset the simulation. So now when I run it again, notice that the location that the part stops is different. So now if I want to verify that the component is stopping at the right path distance, I'll reset the simulation. I'll go to the root node, access the Python script, which you can see here. And I'll go ahead and get the path distance. So I'll use a handle called location equals part dot get path distance. You can find this method in VC component, by the way. And I'll go ahead and print that location. So I'll compile the code. Everything looks good. So now I'll clear my messages panel. So now when I run this simulation, alright, we have a path distance of 200. I'm now going to show you how you can use the component path sensor's Boolean signal with the component signal to trigger tasks during a simulation. So what I'm going to do is I'm going to create a list of parts that trigger the sensor and also get the time that each part was created. So I'm going to create a list and print that on the message panel for you. So I'll go ahead and make this bigger. And let's clear it out. I'll access the Python script. And so instead of using this information here, I'll actually just use signal value if it is equal to true. So of course the two signals that are connected to the sensor, one of those signals is going to return a true or false value. So if the signal value is true, I'll go ahead and get the part. So part equals sensor.component signal dot value. So notice how I'm using both of the signals together. I'll now go ahead and create, let's actually create a handle for a global list. So I'll go up here and create just a dummy list. So order history equals nothing. And I'll define it here because I'm changing it. So global. Alright, so now I'll use that list, order history, and I'll use the extend method. And let's go ahead and what should we get? Let's get the part name that triggers the sensor. And let's also get the part creation time. Make this bigger so you can see it. So when the sensor is triggered, I'm going to make sure it's a true value. And I'm then going to get the component signals value. And then I'm going to print the name of the component that triggered the sensor and also when it was created during a simulation. So I can now go ahead and let's go ahead and print the order history. And I'll reset the simulation and compile the code. All right, and let's see what happens. Clear this out. There's one. There's two. All right, and there we go. And it's just going to keep on going. In this last section of the video, I'm going to show you how you can use real distribution parameters to randomly or pseudo-randomly assign a location of a sensor based on its connected container. So I'll go ahead and go to the Param tab, and I'll create a real distribution parameter here. And I'll go ahead and rename it sensor location. And I'm not going to rebuild the geometry, I'm just going to update the simulation. And I'll use the millimeters, so I'll use distance for quantity and a magnitude of millimeters. And I'll go and click this access button here to set up the value. And I'm actually going to use a distribution of, well, let's use uniform. And let's make the minimum value to be, let's do 200. Oops, sorry, I have to change the maximum value first. So let's do 800. And let's go and do 200. And let's go and assign a random stream of 50 actually. Alright, so that should go ahead and do it. I'll close this out. And now I'm going to create another distribution for the time that, or the amount of time the component actually stops in the conveyor's path. So I'll click the distribution parameter. And I'll rename it process time. I'm not going to rebuild the geometry. I'll update the simulation though. And for quantity, I'll use time and a magnitude of seconds. Click the axis button here. And let's actually go ahead and use a normal distribution. And let's say on average a product is processed 5 seconds. And I'll do a deviation of about 2 seconds. And let's do a random stream of just, 1's fine. So now I just need to assign these parameters to the right properties. So I'll go back to the Behavior tab. I'll access the component script. And let's go ahead and first set up everything. So I have all my handles. Let's get rid of this order history. I'll actually create a handle for the path and the sensor, and I'll do this in a different way so you can kind of see how it all works, because the behaviors are connected. So I'll get the path equals comp dot find behavior. I'll use that, like so. And I'll just reference the path sensors property to get the sensor. So I'll say sensor equals path dot sensors, and because it's a list, I'll use that only connected sensor with an index value of 0. And I still have the simulation. And now, instead of using just the onSignal event, I'll also use the onRun event. So I'll go and change this up. So I'll first define if the signal is equal to sensor component signal, and the value is not equal to none. Go ahead and make this a little bit bigger for you. I know coding can sometimes be kind of boring to watch, but hopefully you're learning. And when the component signal is triggered and I get that component value, I'm actually going to stop the onRun event. So I'm going to suspend the run. And then I'll get the part. So part equals signal.value. And then I'll go ahead and stop the path. So I could just use the path handle, but I'm actually going to use part.container not enabled equals false. So I get the part and I get its container, and then I stop that container, which is also the path. And then I want to print some information. So I'll print the distance that's on the path. So I'll go ahead and set this up. So actually we'll use print that float value with 2 decimal places. So .2f. And then I'll go ahead and get some space. So I'll use the ljust of 50. And what do I want to print? I want to print the sensor dot distance. And I also want to print, let's go ahead and make another line of, let's say, distance. Actually, I'm sorry. It should be time. If I can get that right, there we go. Funny keyboard. Let's go ahead and print also the sim time. So I'm going to get the sensor's distance when it's triggered, and also get the simulation time. So I'll need to create the thing for that. So sim.simTime. All right. So what's going to happen when the signal is received, the sensor is triggered, I mean. I'm going to make sure the signal is correct and the value is correct. And then I'm going to suspend the run. I'll get the component. I'll get the container and stop it. And then I'll print the distance that the sensor has right now and the simulation time. I'll now go ahead and set up the onRun event. And let's go and create a loop. So while true, if the path is on, or actually if the path is off. So when the path is turned off, I want to do something. What do I want to do? I want to create a delay. And let's go ahead and create a delay using that handle of comp.processTime. So remember, parameters are global, so I just need to reference the component and then just assign the parameters. So I'm using the process time. And then I'll just turn the path back on. Like so. I also want to keep assigning the sensor a new distance. So I'll do sensor.distance equals comp. I'll assign that parameter called sensor distance that I set up. I'll then create a delay that uses the process time parameter. Alright, so I'll quickly go over this. So I have my handles for my component, the path, the sensor, and the simulation. I'm then going to use a signal to trigger an event that will stop the main program. I'll get the component that triggered the sensor, stop the component's path. I'll then print the sensor's distance on the path and also the simulation time. And while everything is running, if the path is turned off, I'm going to create a delay, and then I'm going to turn the path back on. I'm also going to assign the sensor a distance, and then I'm going to create a delay as well. So if I reset the simulation and I compile the code, let's see how this all works out. So I'll clear this out. I'll turn the frames off for you. And let's go ahead and get a good view. Slow it down, and let's watch. It seems I made a mistake on line 21. Sorry, forgive me. So I'll go back to line 21. And what's up? Let's see. Sensor.distance. Did I rename it wrong? Let's find out. Ah, sensor location. Ah, forgive me, everyone. So sensor distance. So I'll close this out. And make sure everything is good to go again. Yep. Alright. So I am leaving these mistakes in the video just so you kind of get a handle of how you can handle your errors in management. I'm not just, creating an excuse for why I messed up. So I'll run this simulation. And let's speed it up just a bit. I wonder where it stops. So there's where that first product stopped. We have the delay. And it's not rolling, so I probably have to fix something. So let's see. Ah, I know what I didn't do. And forgive me again. I suspended the run, but I never resumed it after I stopped it. So I have to resume the run. And what these two methods do is they actually start and stop the on-run event. So compile the code. And let's do it again. So there it stops. There another one stops. And it just keeps on going. Alright, this is going to conclude the video. Hopefully it was informative and you learned some stuff. If you do want more videos that do include Python, just let me know and I'll see what I can do. If you have any more questions, just feel free to visit our community at community.visualcomponents.net. And as always, I hope you have a wonderful day.